Hi everyone. This is Mojgan Hakanikar. I am going to present some examples of the things you can do with the NASA archives. I just share. So just a quick introduction about me. Um, I am a physics and astronomy educator, and I get my master in Scotland, Glasgow, and PhD in Kansas State University. I have been teaching since 2011. I have been in Cal Poly, Towson University, and some other colleges. Now I am teaching in City Colleges of Chicago, and also work with the SETI Institute. And also, this is one of my books that is about using abstract concepts more accessible. So some in line with what I want to do with astronomy. So when in SET Institute, I heard about the NCCM project because that is initiated with them. And when I attended their cohorts, I just noticed that there are so many interesting archives and online resources, but there is a just something is missing here, and that is that many faculty they don't have time to create labs for them. So I wrote a proposal to create lab for those resources, and I received two NASA scope grants, and I developed these labs. And the thing I'm presenting is some examples of those labs that I developed, and I'm sharing all those labs with you guys. The complete, but here is just examples. So there is very useful these labs because faculty um, are usually are so overworked, and it is hard to find those, and it is hard to engage students in online settings, and it's also capacity building because you can with them you can just do online and just get many students. So we had first start with 70 students, and now last semester they just increased to 30. This semester we had 75 students, and they're just increasing. So there is a wealth of untapped data that I myself really didn't know before that. So this is what I worth sharing. So maybe some of these data you haven't heard also. So example of those, um, like some, just the list. There are sources for photometric analysis, JS9, that maybe in future, in the previous workshops, maybe optics has covered some of those. You can do 3D printing, spectrometry, sky mapping, like online to go, like on different planets on solar system or on the moons of solar system, and do the landscape mapping. There are a very rich exoplanet archives, celestial objects archives, remote telescopes, that is the older ones, NASA own, and micro observatory. So these NASA Act proposals that I get, it was with collaboration of SciAC with NCCN and also UL, which is the NASA's Universe of Learning. So one example, so I start examples. One of these archives is AstroPix, that is from Universe of Learning. AstroPix has tons of pictures that students can order. And if I go to the link, let me go to the link, and I need to share it with this one now. So you see that you can put a name and you can get the picture here. And for this picture, if you go click the view, not all of them, but many of them has this worldwide telescope. They can have the right ascension declination, and they have so many information about this, and they can go to the also worldwide telescope to see this. So students are getting so much engaged to explore many of these things. And usually one of the labs I developed for this is that they bring a balloon and they find the object on the celestial sphere. They just divide it to right ascension declination, then find it, and they just see the object and they map it. So there is a compare, like the little balloon here. They can compare it and help them to visualize the celestial sphere. So another, sorry, is a question? Um, Another thing they can do with this is doing like galaxy morphologies. Like that is what they did. The galaxy morphologies, they find the galaxy shapes, they categorize it. They could, some of my students were more ambitious. They use Photoshop. This is from the Google, but they did something clear, similar to that. And they just, some of them just put the pictures here, and they understood that this is not like a galaxy evolution. So it helped them to understand and become excited. So this is more um, very easy lab because it just needs not mostly visual, so it can make them exciting. To start it from lower level cognitive demand to higher. The another data archive is IPAC that is created by JPL, I guess. So IPACnet, it is mostly the data you can find here is for cosmological data. So for example, galaxies, again, it doesn't have every galaxy, but many of them you can find here. And if you go, you can get all this information, their coordinates, redshifts, distances, so spectra. So you can do so many labs with this. So one of the labs I give example is that I give them a series of galaxies names, and they search here and they use the redshift, I mean the recession redshift, the cosmic redshift, and this is cosmic microwave background, so they use this one especially. Not, there are so many other redshifts in this list, but this is the one that is for Hubble expansion. And then also they find the distance. So they use this and they find the Hubble constant, which is very close to what, this is a student work. They just put the screenshot of the galaxies and they put their distance and speed. They find that using redshifts, and they find the Hubble constant. So, or they can do their SED diagram. So here, the range that you see here in the SED diagram is mostly, the peak is for the interstellar medium because it is in the range of microwaves. So for example, they can get some average also temperature of that. So many things you can do with this in for the cosmology section. So they have done also so many research projects that is not for lab, but there's a longer research projects that they do in a semester. So I have first one student, because usually these research projects are they don't give them like a credit. So students do this to get something on the resume, to get internships, or they are interested, or they want to get to REU programs. They want to build their resume. So this is why we were had challenged to bring students to these research projects. So first I start with one, and then last semester there were two. This semester I have seven. So they are increasing, and they become more impressed with that. So things that they're doing here, they do some JS9 photometric light curves that you have workshop on that before. They do virtual reality using the 3D tactiles that is on the NASA archives. They do galaxy photomixer. They do exoplanet archives. They find their exoplanet taxonomy, sketching exoplanet light curves for the transit method. and modeling data for NASA archives. So I show example of some of these. These are the list of the most of the things I use with their links. So before I go to these examples, I will want to share with you I shouldn't have put here. Sorry. This is like one of the examples of the research that the student did. So here, for example, they just find the light curve for the Cepheid. So they choose Delta Cepheid and they contact micro observatory, collected 30 days images of those, and they find their light curve brightness based on time, and they draw that, and they find the light curve of the Cepheid, and they find their period. Based on the period, they find their absolute brightness, and using the distance modulus, they find their distance. So I show you in activity how to do this, but just this like one of the research project that it took like a month to do that. So they can do the same with supernova 1A type, and they can find the light curves of that. And anytime the light curves have this shape, it has a supernova explosion, because most of them have the same light curve of all of them, because they just come with the same the Chandrasekhar limit. So all of them have the same. And the absolute magnitude is also defined, so they can be used, both of these as a standard candles to find the distance. So these are types of 3D printing that the students did for the research. Our college has a 3D printing, so it helped them, the lab, to create. And all of these tactiles are free, available in the Chandra Observatory. The link, I can provide the link for you. And sorry, I had a cold this week. So with the same the data that was here, the tactile is one of the students. He created a virtual reality, and he really engaged everybody in the staff when he was presenting it in a symposium. He engaged everybody in the room. So students usually they do these research projects, and then they present it in the symposium. So another example is exoplanet archives. If you search it on the Google, you will get this archive, and it is so useful. You can use it for the class activities, just the quick class activities. It will give you like any of these, it will graph for you all of these methods here. So you can have mass per radius, mass per orbital period. So it will give you that. It just built in the website. But my students just get the data from that, and they try to find this taxonomy of exoplanets, to find the different regions based on their density. So these lines, they just pick here. These are the first group that they manually picked 50 exoplanet. They take out of data from the exoplanet archives. And these curves are the density curves. So look, they take the water, styrofoam, like different materials, they draw the curve, and now they have these regions. So as you see, the water density is this one, the iron density, the styrofoam. So they have the regions for these exoplanets that lies between. So it makes it so much visual for students. So my student get a little more advanced this semester. They just generated this one yesterday. So they created the same data instead of 50. They took all the data, a lot of that, and they use Python programming, and then created this. So the level of students, they are in community college, they are the students who come to the astronomy, intro-astronomy, they are just general students, but the ones that come to the research, they pass some initial math and introductory math and physics. So I have another question here. Thank you. Yeah, I haven't find Joe what is the reason they have this line here. I'm still thinking about it, but I guess that maybe because it is so much data here, maybe it just highlighted that you have some extra. But this green line is not the density lines, but these ones are the density lines that they draw um, with the exoplanet archive. When they download the data, they wrote the Python program to retrieve all this data and then draw those lines. So they have these different taxonomy, like the one that is everywhere. So another interesting thing they did was they draw HR diagram. So this is also they did yesterday. So HR diagram with Sinbad data. So they also use one of the clusters. I forgot one cluster is. We did some try and error with this one because some big clusters have too many data that even it's impossible to draw it. So we need to choose like a smaller clusters. And drawing HR diagram, it is helpful if you do it in one cluster because they are all generated from one cloud. So the distance, because you need to find the absolute distance, absolute intensity. Because of that, if you use just the one cluster, that is helpful. You don't need to find the distance because all of them are almost same distance. So they get this data from Sinbad, and again, they did some Python programming to find the HR diagram here, which I think is very, very close. So I have a question here.
Yes, Machkin. There's a question about whether students taking intro astronomy already know how to use Python.
Oh, these are students who do the research. So I mean they are free to do other things, but these students, they said they are interested because they want to do data modeling. So they choose, so they share with me some interest, and based on their interest, I will define for them something they do with with this data archive. So as you see, the previous students here, they didn't use data like they did manual. So these are they did manually, that they didn't know Python, but these ones they know, so they did it with that. So I think that that is also something you can adjust based on your students. So the research projects are a little longer. So they do usually in the research projects, they get them several sessions, introduction to the concept, and they choose what projects they want to do, and then they will do a project. They do the 3D printing also, and they will learn so much um, presentation techniques because they don't know how to create poster or how to present it. So all of these things also they learn about it, and they go to our English department to do that part. I give them the scientific advice, but they do others there. So let's go back to here. So these are also activities that you can do in the class. So one of the UOL things that I really love is I don't know if you have tried this, but this is so good for introducing concepts and prerequisites. So not so much advanced concept, but to make them engage with prerequisite things. Like if you want to teach them HR diagram. So you can use this link. I'm sending you a link, and I think you can do this in the breakout rooms now. So this is, I share you the link. Um,
And we'll break out into different rooms?
yeah, after I explain them
Okay.
how to do it, uh, uh, yeah, I provide, for the question that if I provide a list of topics, yeah, I provide many options for them to choose based on the things that I think I'm possible for me to advise them. Let me I share this view space. I don't know if you have used view space or not, but this is just amazing. I really like it. Um, so there are so many interactive things here, topics that you can explore. One of the things, because now we are on HR diagram, so we can use this Omega Centauri, and then you can find uh, the sliders here. So you move the slider and then you go to the different part. So qualitatively, you can draw just put a HR diagram beside just side by side, and then use the slider and then try to put like where any of these maps to the HR diagram. So when they, for example, when there is near infrared, you have gas giants here. On the visible light, you get mostly main sequence or orange dwarf star. You get ultraviolet, yellow dwarf star, and mid ultraviolet, um, and multi-wave, and you get a cool red star. So you can put this on the, just map it. So that makes them to understand a little where this goes. So there are other topics here that you can pick based on what is interesting to you. I use this analyzing light here, and I ask them to also change the slider here to see emission lines, and they learn that there is filters in astronomy. So any of the objects, any celestial objects, different portions, what type of filter can be used to see that. So like this is what this is the one I showed. Another one is like here, for example, you can see that, for example, show them the absorption lines and the spectrums. And so they learned just last week, we had this class, and the students really learned about um, the, the Kirchhoff laws and the emission lines, absorption lines, and so many others here. So I think this is a good thing to start the class, and it makes it very more concrete. So that, I think that is good that you start with this, just a little play with this, and then we can go on the next part. Did I send you the link or not?
No, the link or the what you put in the chat ended
Okay.
up just being a copy of the
Oh,
slide.
sorry.
Yeah, that should work. Um,
This is not
so
exactly now that one, but you can find from the menu. Sorry, interrupting you, Chris.
oh no, I apologize for interrupting you. So we'll go into breakout rooms. I'll open up 4 breakout rooms, and how long do you want
Maybe five,
people to?
10 minutes.
Okay, so why don't we say 7 minutes, and then I'll start closing the breakout rooms, and
Okay,
folks can have some time to explore and share.
okay.
Great.
And if you have more questions, yeah.
Yeah, and I think Machkin, you can actually go between the breakout rooms.
Oh, yeah, yeah, I will
to
do that, sure.
chat with everyone.
Okay.
So, all right. So the rooms are opening up. To get to the breakout rooms, you need to click along your toolbar, and there should be a breakout room button, or does it pop out something and says go to breakout room now? Something like that.
What are we joining breakout room for?
Just to explore this website, I believe. Maj, can you confirm?
Yeah, so go to the view space and try to draw the HR diagram for the one that I showed on the top. You can open that one, the Omega Centauri. So try to map it on the HR diagram.
I'll stay out here in case people are joining in late, or someone comes back to the main room to ask questions, but feel free to
Okay, I can
jump in.
go. Okay,
You should be able to go to the other room.
okay, sure. Oh, okay.
Sorry,
I am invited to go to room 4.
sorry.
Okay.
All the rooms are closed.
Okay. So, what do you have any reflections or do you want to have any questions?
Well, I'll just point out that there's a under forms of light seeing through smoke. There's an illustration there of how smoke particles scatter light and how the scatter visible light, how the infrared gets through. I just thought that was particularly interesting. I really like the way the graphic shows that.
I had a question concerning the one that came up, which was Altair. And if you go to the interpretation where it shows, the spectrum interpretation, and then around a light green, it shows that the star is rotating rapidly. How do you conclude that from that graph?
Oh, that's interesting. My students asked the same question yesterday. Um, so I open that just here. Share. Okay, this was this one. And this was,
If you slide over to interpretation,
oh, here, okay.
and then you see
Uh,
that
so I would say that I don't know if I'm correct me if I'm wrong, but the rotating rapidly should be just concluded from the Doppler shift. So if you have a Doppler shift that is showing a higher angular velocity, so you can say that it goes rapidly. So from the spectrum and compare it to the rest spectrum. So if they get blue shift, red shift faster, you can say it can rotate rapidly. Is it good enough, Joe? What do you think?
Hang on, I'm typing something
Okay.
that will hopefully clarify. I agree with everything you just said.
Mhm.
There. It's basically broadening of the absorption lines If the star is rotating, one side will be blue shifted because it's rotating away from us. One side will be red shifted, and it causes the line to be broader than it would otherwise be. And you have to be careful because there's also other things that can broaden the spectral line. So you have to account for all of those other things before you say, oh, the star is rotating.
Yeah, there are different type of redshift also.
You can see that somewhat easily in the spectrum of the sun. You can see the broadening due to the rotation
Mhm.
of the absorption. You can see the broadening of the absorption lines due to the sun's rotation.
So, any other questions or any impressions? Okay, so let's continue. Okay, the other thing is the other activity that you can do in the class. So I think you did you checked this also on a view space. You can generate tons of activities from view space. And another one here is Cosmic Light Show. I create this activity and I share with you this activity. So it just teaches students about the different filters and how it teaches them that any um, pictures or images that astronomers create. So they have this misconception that everything comes with one telescope, but they just blend all of this with the different filters. So with this activity, as a prerequisite, I introduced to them that how different parts can be seen with different filters. Like there is a region you can see with the X-ray, or we can see in the infrared filter, or the visible light, and then they after that they will mix them all and they see that combination. And you can have a chance to work on this also in a breakout room in a minute. But before that, I want to show you that after they do that part, they go get introduced to that concept, and through lab activity, they go through um, micro observatory JS9. And we use this JS9 in two model. For the class, we just ask them to generate artistic pictures and with their taste. And there are some tutorials online, very short tutorials. And they just learn it in a 15 minutes in a session. So they bring so most of the images are fits images in astronomy. So they can just open with the JS9. So you cannot open it with other app. So they have archives here. From these archives, you can bring the pictures in the JS9 and start to coloring it. So with that coloring, mixing, they just blend two image, and it just is. My students yesterday did this activity and they generated these interesting images themselves. So the one on the left is from the research work. On the right is they just create yesterday, and they blend these two images from the bottom and the top, and they create these amazing images. They colored it. And then go further for the research part. I combine this with IPACnet. I say this object that you find here, go and see what the spectrum they are, and based on the spectrum, color it. So they will connect that to their real color. So, but they could do just artistic one, and they can. There is a gallery on the just micro observatory, and then a photo contest that they can participate. And so I think this was a really good one here. Sorry. So I want also, this is another activity I want to try in breakout room. So this is this. Somebody ask question here?
Yeah, so there was a question about your activities and whether you have them as PDFs or text documents, or are they part of a learning management system that people could?
Yeah, so all these activities I developed as a NASA grant. So I am going to share with you guys. And it is a Google Doc, and everybody can have access to that. And I also send an email to AAPT Astronomy community, all these activities when I developed it. So if you go to that community, you can find it of course, I can share it again through optics. Definitely. So
That would be great. We can always put a link on our website
mhm,
to the activities as
sure.
well. So.
And I appreciate everybody give their feedback and what can be done better, or yeah, yeah, I can post the link in here too. I do that right away. So I also need a survey um, to see how we can do this better. So these are two activities. One, it was from Universe of Learning. This was that. And there was another one with NCCN. As you see, I work with the NASA scientists. They give me so many feedback on all this. And you see some of the comments of Kelly on the light. All of those comments, I address them, but I just put them there to remember what she gave me. That is why I didn't delete it, but I address all of those comments. So I want now you go to this micro observatory. So let's generate one of these interesting images like that. So let me I send you the link. Um, okay, this is the link for micro observatory, and if I share this. So you can have these, there are tutorials here that you can watch when you have time, but tutorials mention how you upload pictures, how you can blend them, how you can change the scale, how you can change the color. I summarize them here that you can just try something, and when you have time, you can go and read this and help your students. For example, here are archives of the images, but you can also have your own image from telescope. Like if you are doing like with the EV scope or unistellar, or you are just can order also remote telescopes to micro observatory if you want a special target. You can do that too. So imagine that we have this Crab Nebula here. So this is a fits image. You need to open it with this, and then you can change to see which one really make it better. Why we cannot see anything? Maybe it didn't catch it. So let me I do this one.
Which image did you get there, Mudgen?
I did Crab Nebula,
Okay.
but why nothing appears today? Oh, because I put this color, maybe gray. Let me choose another thing. Okay, I do it lagging. I can do a scale, usually log, and we change the contrast. So for the objects that are far away, it's better to use log. And then you can change the color here, like a magma. And you can just change the color. I like this one better. And then you can also do another image here, like another one that takes with another observatory, like the infrared part, so they can learn that. So this micro-observatory cannot show two images at the same time. You need to do any one at the time. And then you can color that too. Or rainbow. Okay, let's try this. And then you can use this blending tool. And then you can blend them. So you can get the combination. And my students yesterday worked with this and generate that interesting images I showed you. They told me this was the most exciting experiment they have done. They really enjoy it because it is fun. So what they get from this is that they learn that astronomers how put the different images from different filters together to create these images. And then when they create this with the microobservatory, they learn the skill, and then they use when they get more skilled about this, they use the IPACnet to find the real filterings, the real lambdas, and try to match more close to that. So in this way, they learn more about ENM spectrum and how different regions have different pictures, different filters of the cosmos, and many things like that. They learn indirectly. So do you want to have a breakout room for maybe 10 minutes to try this?
Before we go there, the first document link you put in the chat, we have no access to. So
Oh,
the permissions need to be changed.
okay. I will go and change that. Sorry.
That would be great. Thank you. And
I
then,
also, oh,
Yeah.
sorry. I just the one that you have here, that is that the Spitzer Lagoon infrared? That's what you on the archived images. I was just wondering which archived image you picked. I missed that.
Yeah, I use this too here, but you are free to do anything you want. You can do the Whirlpool Galaxy. I think I did this lagoon here. Here I did these ones.
Okay, perfect.
So,
so I'll open up some breakout rooms once you're ready, Majken, and we'll have about 10 minutes for folks to play around with one of the documents.
yeah, I will open the document. So I just get Joe asked when the students asked did the activity, did they comment about images not being as pretty as the images they see in the news or other media? No, they were very proud. And then they told me that I have a permission to use it today. So, yeah. Okay. So yeah, we can go to breakout room.
Great. We're ready. I'll open up the breakout rooms then.
Okay, everyone, do you have any feedback about this one?
Is this
Or-
activity included in the links that you sent in the chat?
yeah.
Yeah? Okay, thank you.
Mm.
In the links in chat. Okay.
Yeah,
I
I
would
will
just
give
say,
the link.
Majkin, I'm
Yeah.
sorry.
Yeah, go ahead.
I was just going to say, I counted close to 70 pages total between those two documents. You have done a wonderful job
Thank you.
at compiling all of this activity. I mean, you could easily publish this as an astronomy lab book. Have you thought about doing something like that?
Yeah, I thought about it, but they say it should be 200 pages. Can I publish with 70? But
Well,
anyway, this is like a grand thing, but yeah, I can still publish it to make it available to everyone.
but I think you've done an admirable job of packaging these up and given us a lot of choices uh, for things that we can do.
Thank you. And I also want to publish it in Physics Teacher soon. So I'm working on that, and the links will be there.
That would be great.
One new.
Yes, and I've put the links on our website as well. So, in some ways you can say that it will be published.
Well, I mean, technically, yes, it is published.
Yeah, but where can I publish it for a lab? That would be great if I can.
I'm sorry, what?
Where can I publish a lab? I have also so many more ideas. These were just examples for
Well, nowadays you can self-publish.
oh, self-publish. Okay. Yeah, I have so many more ideas. This was just for a limited time. That was 1.5 years for those NASA scope grants. I create these examples. And if the SciAct grants continue, so hopefully we can apply and do much more.
So one
Okay.
thing that I recently did with your publishing question is last year I created I'm a geology and astronomy professor, so I created a geology class and I published it on the LMS. I used Canvas, so there's something called Canvas Commons, and that's a place to publish the course and activities, and that's what I did.
Oh, nice. Okay, I just learned something new. I need to follow up with you to see how should I do that. So people can integrate to their Canvas then or Blackboard.
Yeah, they can just simply download anything that I created for the course. And you can publish anything. It could be a module, it could be a PDF, it could be anything. And then people can look up your name or look up the subject and that resource will appear and then it's easy for them to just plop it into their course.
Okay, I will do that.
And
Thank you.
Majkin, you might could also put some or all of this on Compadre
Yeah, I
and
would
make
love
it
to.
available to the physics teaching community.
Sure, I will do that definitely. Yeah, I just sent the email to astronomy community, but I didn't, I just forgot compadre. Yeah, I will do that. I will contact Bruce for sure.
Fantastic.
Okay. So the next thing is cosmic ladder and standard candles. So when I teach astronomy, I noticed that the student had much difficulty to understand standard candles. And so the cosmic ladder, so then start with parallax. So the parallax, you know that it is limited. So after some distance, it is not that that the angle is not anymore can be identified. And with the new horizon and the new level that the technology of the telescopes provided, the space telescopes, you can expand that parallax to the further distance, but it still is limited. So at some point, this will not useful. So the next level is standard candles. There are some simulations even in UNL on different types of star variables that can be used as a standard candle. The standard candle is um, any object that you can know somehow their absolute luminosity. It means that you have the brightness at the point that the star has, not the brightness that appears on our when we see it with telescope. So one of these activities I developed was based on Cepheid. That was very difficult, I think. So students can do this activity both in class or as a research project. So my students did both. So if you do it in class, you can just give them some ready graphs that they can find the period easily of the Cepheid because they are just getting dimmer and brighter. And they periodically this happens. So, but also you can, as a research project, my student did this and they find the light curves themselves. So this is a light curve they find for the Delta Cepheid. So they collected the image from micro observatory, they ordered for 30 days. And for the 30 days, they put it in JS9. One of you asked about the version of JS9. This is the more advanced version of JS9 that you can upload the object here, the pictures. And so I think there is another workshop in optics that they teach you how to do this. You can find in the JS9, in fact, the brightness using, but first you need to find, when you upload the feeds file here, you need to find the Delta Cepheid because sometimes Delta Cepheid this map is very confusing. So there is another website that this is the lesson we get from JS9, in fact, experts. So you will go to this AAVSO website. They have the map of the sky. You can compare it and see where is exactly the Delta Cepheid is. And sometimes it is just upside down. You need to make sure that it's not upside down. If it's upside down, you cannot just turn it, but you need to just try to match and find where similarities is within those pages and find your target. And then you need to find another star that is like your star that is a reference star that you compare the brightness, and some known stars, some star that you know their brightness, so you can say how much this is like brighter. Based on that, you can find the brightness. So if you record this brightness over just just like a period of time, it's just like a time sequence project. After a long time, you can find the period of Delta Cepheid, and that was one of the research project, and you can do that for any light curve. So you do this method to find the period of the exoplanet, like for the transit method, or you can use it for finding the supernova 1A, or many things. Anything that needs light curve, you can use this method. I just had last year we had another workshop with NCCN that Smithsonian has created a very ready to go Smithsonian ready to go transit exoplanet projects. Data is much more easier to access than this one, and you can use also that. So I think I get some questions here.
Just sharing resources.
Oh, okay. So this is another research project that you can work with the students. And so if you have another time for activity, for example, I can, so maybe you can use the simple one for the class. So using this graph, first imagine that this is one of the NASA generated graphs, and the period here is like 31 day, 31 4 days. So you have the brightness and you can see the period is given. So based on this period, how we can find the distance of this delta Cepheid? So when we find the light curve here, my students find, so she find here, where was that? Okay, here she find like about 6-7 days or 5 days. So after you have this, after you have the period, oscillation period, this is the this graph is given, is just something for delta Cepheid. So based on their period, if you go to this graph, you can find their absolute magnitude. So you can use now this, like with this, if there is about 7 here, you can find where is the absolute magnitude is. And this is why I make the Cepheid's standard candle, because using this graph linear, if you have the period of oscillation, you can go here and right away find their absolute magnitude. So when you have the absolute magnitude and apparent magnitude, you have them both. So here she finds the apparent and the absolute brightness. From here, you can calculate the distance from distant modulus. So I want you in the breakout room, maybe 5 minutes, using this period here for this one and find the distance. And this one is, I think it's a V star, I just remember, but it's on the Google. So something that I use is a UNL calculator, because many students have difficulty. The students coming in general astronomy are very weak in the lab, in the math, so they use the distant modulus simulation. And you can go, this is also in my, it is in my worksheets that I gave you. So they just put the apparent and absolute brightness in this calculator, and they find the distance, then they compare it with what is online, and they can just compare it and see that they are correct. So the absolute magnitude is with the M, big M, and the small m is the apparent magnitude. So if you put there the difference, it gives you the distance. Do you think you want to do this, or you are good? But it's up to you.
How do you guys feel? Do you want to give this a try?
Maybe I finished to see how much time we have, and if you have time, maybe they can do this. Is better.
I'd like to go on.
Okay, I will continue then. Okay, so this was another example research you can do, and this is the 3D stuff that the students, they were getting so excited about this 3D stuff. They just generated some Christmas gifts out of this last semester. So, and this is the virtual reality one. For this one, you can go to Chandra Observatory. I think the link is also in the worksheet. We talk about this one. Another activity is exoplanets. This is not in the worksheet. I haven't put that because it wasn't part of the NASA scope, but for this activity, you go to Eyes on Exoplanets, and you can verify the Kepler's law. I usually do this for when I teach the Kepler laws. I send them to do this activity, and they can have the planet's name. Sorry, if it is a group, they find a group. It's a gas giant, or it is Neptune-like, and they find their orbital period, eccentricity, and then they find the Kepler equation. So the Kepler equation has a little modification for exoplanet, that is a cubic over period squared is equal to mass of the star to the mass of the sun, instead of to be 1, because of when you have a mass of the sun to the mass of the sun is 1. But here, for the exoplanets, so you know that the Kepler equation holds for any anything that orbits, and then you can use it for that too. So the students get so excited because here they do it like in a groups for 30 exoplanet, and they see all the time these two last columns are very close, and that makes them that they feel that they are just verifying Kepler's law. So I also share this with you. So this is so they can go here, they just choose the planet type. So they have several tables that fill it for gas giant, Neptune-like, super Earth, terrestrial. So when they go there, they choose, for example, gas giant, and then they choose one. So it shows the system, the planet itself, and it's a star. So for this lab that I developed, we can develop more other labs, but the one that I developed is, and this archive has really many of these exoplanet, like 6,000. So you go to this little plus sign here, and here is the information they need for the lab. They have an orbital period, orbital radius, and they have a eccentricity, and they have the mass of the star divided the mass of the sun. So if they pick up this number and they find orbital radius to the power of 2, this orbital period, so they can find, they see that this is equal. So, but there is some trick here. So this orbital period, it should be in terms of Earth years. So some of these exoplanets have days. So if they have days, they need to divide it by 365, because that is the only way that the Kepler, simpler Kepler equation is true, because this should be in terms of Earth year, and your distances should be in terms of AU. And the mass of the star should be also in terms of the mass of the sun, and you put this ratio. So this is also one other activity that you can do for that. So go back to the PowerPoint. Okay, I don't know if you have tried Moon Trek, Solar Trek General. This is also very interesting. So I have one activity on this one that you can find the risks of moon landing based on where is volcano, where is non-even, or things like that. So NASA Solar Trek usually do a map on the solar system on the different things. So let's try that. I just show this one also. This is very good for teachers, especially because it is very tangible. So mostly I think it's good to start astronomy with very tangible concepts rather than go to JS9 or light curves. So this is so simple. So for example, you do the explore tricks. Usually my students do the solar system and they just find so many new things. It's a NASA eyes, it's called NASA eyes because there are so many eyes on things that they could see things that maybe when many eyes look at it, they discover new things. So there are so many things they find, like last time they were finding some ice regions in one of the planets or so many things. So example for this special activity that I wrote, we can go to the moon and they are here some tutorials again. And so moon trek, so each of them has have a trek, so you can do the tutorial. I skip it for now. And then here is a fly to, so they can put the latitude, longitude here. And when you click fly, it will take you there. I don't know, maybe they have some error today that it doesn't go. Last night I tried, it didn't go too, but usually it does. So when you put that, it will take you to that, oh, it is here. So maybe I need to use another latitude, longitude. Anyway, it takes you to that place. Very nice. It flies. It shows usually a spherical shape. I don't know why today it's not working. So let's try this one. So this fly to latitude, longitude is for any of those objects that is there. Some of them hasn't been completed yet, but they are, so many of them is in progress. So, so if you go to the menu, it calculates distance for you. So you can do line, like you can choose two parts. Like one of the activities, I tell them like find the diameter of the crater, or there is also, they can find the heights here. They can do data plotter. They can calculate elevation profile. So if you draw these here, it will give you this profile and you can find the depth of the surface. So it gives you so many information about that you can help the students to play with this. But usually it's spherical. I don't know, something is wrong with the website today that doesn't go, but it really fly to everywhere on the moons. There is so many other tricks here. They do these kind of things, a calculation for every other planet. And there are some also 3D printing stuff here that the students can do. If you just not want just do the Chandra observatory 3D printing tactiles, you can use here too. And you can also go, if the students have virtual reality, they can go to this mapping in any place here, not just moon, in any place on solar system with virtual reality. Okay. Yeah, Yeah, I use it for the geology. I took physics 110, something like that. I didn't know it's all geology because I'm not geology expert. And I thought it's physics, but it was so much geology. So I had to learn geology. And I think this was very useful for that class. And then also, we used what is it with Google, the GeoEarth, something like that. We use that too for that class. And some activities on that to find the rivers, wheat, and things like that. So after we developed this, we did some validity and reliability check with all the these worksheets I share with you is reviewed with subject matter experts of NASA because you know that NCCN has the SME Connect match that it can match you with SMEs. I don't know after the grant is now haven't renewed. They have done that too. I should check, but it was so fun. In these 5 years, we could match with SME. They bring them to their class or they check our stuff. So that was all helpful. So they reviewed this and also we did error analysis with the students who used it. After several times I checked with the students, I see the places that they had difficult understanding. I revised them. And also I did the consistency with faculty survey. Several faculty also give me comments. And it would be great if you also do that too. As many as faculty that just having comments and use it. Okay, the fly to works. Maybe you can share it later if yours work. I don't know what happened to my so I think this enriches the laboratory sessions. Main thing is cognitively make the students engage because it connects different modalities. My kind of in background from cognitive perspective, my goal was provide lessons that connect different modalities and be more interdisciplinary. And they have also some computational component into that and have something for different levels and from provide the online engagement and increase the capacity learning. So this is the poster that my students, the first students who was brave enough to come to the class, she presented this poster in the symposium. And this is my eye poster and a AAS. You can have access to that too. It is online. These are some of the students' feedback, and that is the letter from president that give appreciation to myself and the students. So some of the other things we did also some other projects here, which I explained, I think. At last, I also developed so many stuff with the Stellarium. That is not part of this project, but that is also what I do. So these are the references. And I also have a EV scope. This is one of the pictures I took myself in a dark sky. So I don't think my survey link works, but if you just do the survey and give your feedback, I really appreciate that. I share it with Chris and then she may email you. Okay, I think I have a question here. Kepler Laws activity, do you have a Google Doc for that? Yeah, I can share that with you guys. In the Okay, I am here for any questions you may have, and if you want to do any of the activities and try them. This the time looks like it's another 10 minutes. Thank you.
Thank you. And
Mhm.
please, people,
Thank
Ask
you.
or share.